smartest of the students. They know that I'm insane.
I've got a blank space, baby, and I'll write your name.
I'll write your name in the book of higher level mathematics. Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. Let's get right to it, shall we? Shall we? Shall we? And finish our discussion of planes. Planes part 3. We'll check back in with T-Swift towards the end, or at the end. So we are going to find the parametric equations of the line through these 2 points. And then we're going to find where that line meets this plane. It's going to be great. So in order to do this, we better find the direction, yes, of this particular line. And we can do that by finding vector AB, which is clearly equal to 3, -2, 6. Okay? So the parametric equations for line AB, which we'll symbolize like this, must be what? X must be equal to -1 plus 3, we'll go with lambda. Where did I get that? Well, here's A. I could have used B, I suppose, but I used point A here. X equals -1 plus the direction 3 times lambda. Y is going to be equal to 2 minus 2 lambda, right? Yep. Okay. And then Z will be equal to 3 minus 6 lambda. Booyah. Very simple, very easy. So this line meets this plane. Now I'm going to substitute these values here, these parametric equations, into this equation. So that would be, replacing x, I get -1 plus 3 lambda minus 2 times y, which is 2 minus 2 lambda, plus 3 times 3 minus 6 lambda, and that has to be equal to 26. I'm not going to go through the algebra. I will tell you that lambda is equal to -2, yes? So then to find the coordinates, once I know lambda, I am in business, yes? I would do -1 plus 3 times -2 and so forth, and I can say that the line meets the plane after I do that at -7, 6, 15. Again, how did I find that? I used the parametric equations and the value for lambda that I found. Easy peasy pumpkin pie. Suppose n is the foot of the normal from A to -1, 3. Okay, so n isn't the normal, but it's the foot of the normal. Yes? And here's A, which we know is to -1, 3. Oops. And we know right here is n, and so it's perpendicular and stuff. To this plane that has this equation, find the coordinates of n, so I'm looking for n there, and hence find the shortest distance from A to the plane. So that's just the magnitude of this vector here, is all I need to find. Okay? So let's say I have a normal over here, yes, and it's of course perpendicular to the plane. Well, this plane right here, that's the equation of this plane, it has a normal vector. What's it going to be? It's going to be the coefficients of this. Remember, A, B, C. So that would be 1, -1, 2. So that's the normal vector. So that means the parametric equations of line AN are what? Well, x would equal 2, yes, plus 1 times, we'll say t. So 2 plus t. Y would equal -1 minus t, right here. -1 minus 1 times t is -1 minus t. And then z would be equal to 3 plus 2t. Isn't that fantastic? Okay. So now using this equation, we're going to substitute these parametric equations into here and solve for t. So I'd have 2 plus t minus y, so that'd be minus a -1 minus t, plus 2 times z, which would be 2 times 3 plus 2t. Nice. And that has got to equal 27. Doing some algebra, which I will not show you, we get t equal to 3. So that means that the point n has to satisfy these parametric equations. So that's going to be 5, replacing t with 3, 5, -4, and 9. Okay? And I already know that a is 2, -1, 3, so I just need to find the magnitude of vector an, or it's just the distance from a to n, if you want to think of it that way, really the same thing, because I know that the foot of the normal from a is n, so that would be the square root of all this junk, this minus this, so what, 5 minus 2 squared, plus -4 minus a -1, so that would be plus 1 squared, and then plus 9 minus 3 squared. And without doing all the arithmetic, I will tell you that that is equivalent to the square root of 54 units. So that is the shortest distance from A to this plane right here. And then the final example, giddy up. Suppose n is the foot of the normal from A to -1, 3 to the plane with this equation, I plus 3k. So this is a known point. So that would have coordinates 1, 0, 3. I'm going to put that in my back pocket. 1, 0, 3. Plus lambda times this vector in the plane plus mu times this vector in the plane. Find the coordinates of n. All right, we got a lot to do here. Okay. Well, first we got to find a normal direction vector. Well, I have two vectors right here that are in the plane, so their cross product, in other words, this cross this, is going to give me the direction of the normal perpendicular to that plane. So that means I'm going to take 4i minus j plus k cross 2i plus j minus 2k, and that is going to look like this. That's going to be I, j, k, yes, 4, -1, 1, 4, -1, 1, 2, 1, -2, 2, 1, -2, and the cross products are going to look like this. So eliminate this row, and I have -1, 1, 1, -2, I, and minus 4, 1, 2, -2, eliminating this column right here, j, I think I said row before, that's bad, plus 4, -1, 2, 1, k, and I got that by eliminating this row, okay? And without going into, working the cross product here, -1 times -2 minus 1 times 1 times I, blah, 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 blah. That gives me the vector 1i plus 10j plus 6k, or 1, 10, 6. So now I know that the direction of the normal is 1, 10, 6. So the equation of the normal through A is equal to what? XYZ. And I know that A is 2, -1, 3, plus T times 1, 10, 6. Okay. And so then I know that n must have coordinates for these parametric equations. And that would be the coordinates 2 plus t, -1 plus 10t, and 3 plus 6t. All right, so now we're finally getting somewhere. Okay. We also know that n lies in the plane, so that means that it must be equal to 2 plus t, or each of these parametrics must be equal to this vector equation, right? So that would be the vector equation of this plane, because it's in the plane, so this must be true. 2 plus t, well, no, let's do it this way. 2 plus t, -1 plus 10t, just to make sure we're clear here. and then 3 plus 6t. Okay, so those are some components here. That must be equal to, let's see, 1, 0, 3 right here. That's the point that I know that is on the plane for sure. Okay, plus lambda times 4, negative 1, 1. These are the vectors that lie in the plane. Plus mu, using the same strategy, times 2, 1, negative 2. Okay, so if that's true, I'm not going to write all this down because I'm running out of room, but 2 plus t must be equal to 1 plus 4 lambda plus 2 mu. Negative 1 plus 10t must be equal to 0 minus lambda plus mu. And 3 plus 6t must be equal to 3 plus lambda minus 2 mu. Okay? And if you simplify all of that, this first line simplifies to this. 4 lambda minus 2 mu minus t equals 1. Negative lambda plus mu minus 10t is equal to negative 1. And then lambda minus 2 mu minus 6t is equal to 0. Okay? And so I will tell you, and I'll show you how we're going to get these answers in just a second, that mu is equal to 40 over 137. And that, lambda is, mu is equal to negative 7 over 137. Wouldn't it be great if I could do this in my head? And that t is equal to 9 over 37. Okay, and substituting 137, sorry. Substituting these back into the parametric equations, I get the point 2 and 9 over 137. I get negative 47 over 137, and I get 3 and 54 over 137. So those are my coordinates of n. But that's all incumbent on being able to do this. And we do this with our handy dandy calculator, menu, algebra. And what I have here is a system of a linear equation. So the number of equations I have are 3. The variables are x, y, and z. And now I just have to set up my equation. Lin solve x, y, z. So this is 4x instead of 4 lambda plus 2y minus z equals 1. And then negative x plus y minus 10z equals negative 1. These are the simplified equations from before. And then I have x minus 2y minus 6z is equal to 0. And I want to have those as fractions. So I'm going to go menu, number, approximate to fraction. And I'm going to do enter. And there we go. 40 over 137, negative 7 over 137, and 9 over 137. Let's just double check that. There they go. We are done with that. So let's go back to T-Swift. Hope you enjoyed this awesomeness. And it is not going to go down in flames. I am okay.